So in this video, we will discuss about the riveted cylinders. Okay, these are also thin cylinders, but the cylinder is formed with the joints. Okay, that is with the help of the rivets. So we will discuss the riveted joints here. Okay, so normally some of the pressure vessels, especially the boilers, they are very big in size, right? So whatever the diameter and the length, because to store the high pressure steam, the boiler is the formed here. So this boiler is not, it is one component, so it is not formed, it is the for it is formed with generally the fabricated with joining several pieces. Okay, so same material, but they are fabricated the bit by bit. They are taken the plates and they're folding, and then they are attaching one more, like that it is formed a big the one particular cylinder here. Okay, so if you see here, these are different plates here. This is one plate, this is one plate, they folded together, and here it is for one cylinder, and here also one cylinder, and here also one cylinder. 1 2 3 plates are there. It means this is normal, the example here, 3 plates, they are folded, and then they are riveted. They drilled a hole and they place the rivets here. Okay, and these 3 cylinders again joined with the help of this here. Okay, so this is one connection, one rivet connection, and this folding is one connection here. Okay, so you will get 2 types of the joints here. 2 types of the joints. So one is the longitudinal joint, and one more is circumferential joint. How you differentiate the longitudinal joint and the circumferential joint? So longitudinal joint is this one. Whatever the plate you are taken and you are folding, and here you are placing the holes and rivets. Here the plate you are making a circle, and here you are placing a drilling a hole, and the rivets, putting a rivets. This joint is called the longitudinal joint here. Longitudinal joint. Okay, and the after making same two plates, they want to join together, and this joint it is called, this is circumferential joint. This is the circumferential joint. As I saw here, you can see picture here. The one is longitudinal joint, taking and folding, that is what are putting the joint, it is called longitudinal joint. And after making similar plates, again you have to join 1 or 2 or more, right? This is 2 together, if you joint, this is circumferential joint. Okay, so this is how the cylinder is made, the boiler cylinder. Okay, now if you come to the design criteria, the strength of the, because of you are drilling the hole here and placing the rivets, here also drilling the hole, here everywhere, the strength of the plate will be reduced. It means what are the efficiency? Now efficiency will be comes into picture here. So efficiency will be reduced because of the drilling the holes here. So efficiency is one of the design criteria. Now if you see that the efficiency is defined as, what is the efficiency? So efficiency of the boiler is defined as the ratio of the joint, ratio of, it is strength of the joint. What are the strength of the joint with respect to strength of the solid joint here? That is, the strength means it is force. Okay, strength of joint divided by strength of solid plate. Strength of solid plate. Okay, this is the efficiency of the boiler. That normally I can write as a strength is nothing but force at the joint divided by force at the solid part. Why we are designing efficiency? Because the force will be reduced because of the drilling the holes. So that's why we have to check the efficiency, how much is there. Otherwise it will fail. Okay, now we will go for the 2 types of the joint, 2 types of joints. As we know that one is longitudinal joint and one more is circumferential joint. First we will go for the longitudinal joint. Okay, where is the longitudinal joint here? The longitudinal joint is this one here. You are folding and making a joint. That joint is called the longitudinal joint here. Here again we have to first equate the fluid pressure, bursting force is nothing but the joint force and the resistance force. Two types of the strength it will come, and equate both for equilibrium, then we'll get the efficiency here. Okay, so now the joint, that is bursting force equal to FB. This is nothing but the joint force also, whatever the bursting force, because that is Fj, that will be equal to, inside the cylinder fluid is there, as previously we derived in the beginning of this topic here, to derive the circumferential stress and the longitudinal stress. Similarly here also you should go like that. That is pressure into 2 times thickness into L. That is thickness 2 times into L, where T is the thickness of the wall and L is the length of the cylinder here. That is Fj, joint force, or Fb, bursting force. Now opposite to that, what is that? The resistance force, right? The resistance force means it is a strength of the solid plate. I'll write here strength of the solid plate equal to Fs, that is force of the solid plate, equal to, here the we are deriving the longitudinal, the related to this one circumferential stress will come, right? You are folding a circumferential stress, here it will be acting circumferential stress. I am writing circumferential stress into 2 times this is PLD, this is P, pressure, into L into D, whatever the length along with that and inside diameter, right? This is PL into D. The strength of the solid plate is sigma C into 2T into L here. Okay, so now efficiency of longitudinal joint, that is efficiency of the longitudinal joint. What is the formula? The force, strength of the joint divided by strength of solid plate, right? Strength on the joint divided by strength of the solid plate. Now substitute, strength of the joint is how much is there? PL into D, divided by the strength of the solid plate is how much? That is sigma C into 2T into L. Okay, so how much we will get here? The efficiency of the longitudinal joint is, that is PD by 2T into sigma C. This is the efficiency of the joint. See, same like previous, the circumferential stress is PD by 2T. Here longitudinal efficiency is PD by 2T into sigma C. Okay, this is the longitudinal joint. Now come to the circumferential joint. Same, we have to equate circumferential joint. Just I'll erase this and here. Circumferential joint. For circumferential joint, this is your circumferential joint, right? The bursting force, how much is the bursting force here? This is again P into pi d square by 4, along with the circumference, pi d square by 4. This is the joint force or bursting force. Now related to opposite, the how much is there? That is P into pi d square by 4. Next, the solid plate, strength of the solid plate or resistance force equal to, that is the sigma C. Instead of sigma L, here the sigma C it will come. That is circumferential stress into pi into dt, pi into d into thickness, total diameter and thickness into pi. Now for efficiency of the circumferential, circumferential efficiency is the joint force divided by the solid plate force. Okay, substitute, how much is there? pi by 4 p into pi d square by 4 divided by sigma c into pi dt. Okay, simplify, we will get the efficiency of the circumference. Circumferential efficiency is PD by 4T into sigma c, sigma L, sorry, this is sigma L, here sigma L, and here also sigma L, because this is circumferential, related to that longitudinal it will come in the previous. Okay, here also this is sigma L. Okay, so this is the second formula you have to remember. So total riveted joint related to calculation of the efficiency of the cylinder. You will get two types of the efficiency. One is the longitudinal efficiency and one is the circumferential efficiency. Okay, so for longitudinal efficiency, what is that? PD by 2T, right? PD by 2T into sigma C. Here for circumferential efficiency, PD by 4T into sigma L. These two are the same, vice versa. Just compare it, the sigma c how we will derive and sigma L how we will derive in the previous derivations. The little bit changes are there. You can easily remember here these two. Okay.